is the look here, write the equations of motion for a particle rotating about a fixed axis. So we have idea about the equations of motion. When the body is moving with uniform acceleration, we know about some equations of motion. What are those? V is equals to u plus at, s is equals to ud plus half at square, v square minus e square is equals to 2as, and Sn is equals to u plus of a of n minus of. These are the four equations. Generally what we can feel, these are the equations of motion. These equations are valid when the body is moving with uniform acceleration. At the same time, these equations are for only translatory or linear motion. What is meant by linear motion? If the body is moving along a straight line, that is what you have to say, it is linear motion. Then only those equations are applicable. So I think everyone has idea about this one, because from lower sections onwards we have idea about those equations. But in this chapter we have to apply the equations of motion for rotatory motion or rotational motion. How we can write them? Let's discuss. So dear students, very simple. To write these equations you have to remember, in case of linear motion, s is the displacement and u is the initial velocity. What it is? Initial velocity. And what is v? V is the final velocity. And what is a? Acceleration. And t is time. And Sn is the distance traveled in nth second. So the notation should be like this: S means displacement, u means initial velocity, and v means final velocity, a means acceleration, t means time, and Sn is the distance traveled in nth second. Like that, here in rotational motion the same terms should be identified like this. Here s is the displacement. Now here theta is angular displacement. So we are adding some one word, angular. That means the body is in rotational motion. Theta is what? Angular displacement. And what is u? Initial velocity. Now here omega 1. That is initial angular velocity. Clear? And what is omega 2? Final angular velocity. Clear, children? And what is a? Acceleration. Now in this case alpha is called angular acceleration. As usual, t is what? Time. Same in both cases, same. And what is theta? Here Sn, theta n, that is the distance, angular distance traveling nth second. So to write the equations you have to observe the difference like this. S is the displacement here and theta is angular displacement. U is here initial velocity, there omega 1 is initial angular velocity, and here v is what? Final velocity, there omega 2 is the final angular velocity, and a is what? Here acceleration, and alpha is what? Angular acceleration. And here t is time, here also t is time, and Sn is what? Distance traveling in nth second. Here angular displacement in nth second is given by the theta n. So by using them you have to compare the equations of motion in both cases. Let's go for that. First we can write the equations in linear motion. Let's go for that. So for displacement we can write like this. Displacement is s is equals to u plus v by 2 into t. S is the displacement, average velocity into time is nothing but displacement. That's the same equation should be written as in this case like this. Just now only told you what it is. S is the displacement. Here now angular displacement, theta is equals to omega 1 plus omega 2 by 2 into t. Clear? And now for acceleration how we can write? A is equals to v minus u by t. acceleration is equals to change in velocity by time. So now here in this case we can write angular acceleration. So how we can show that? Alpha is equals to what, right? Final velocity, angular velocity minus initial angular velocity by time. And now third one, what we know? V is equals to u plus at. V is equals to u plus at. In this case also we can write the same thing here. V means what? Final velocity. Omega 2 is equals to what is u here? Initial velocity. So omega 1 is initial angular velocity plus a means here a is what? Acceleration. Instead of that what, right? Angular acceleration. Clear? And same thing now here. Equation number 4. What we know? S is equals to ut plus of ad square. So the same thing we are writing here now. In case of rotational motional, S is the displacement here now. Angular displacement is equals to what is your initial velocity? Omega 1 t plus of into a means what? Acceleration. So here angular acceleration. Clear, children? And now next one. Fifth equation is there. V square minus u square is equals to 2as. Same thing here. V is the final velocity. That's why what, right? Omega 2 angular velocity square minus initial angular velocity square is equals to 2 into a means here acceleration. Here now what, right? Angular acceleration into theta. Here displacement, here is angular displacement. And now here final one, Sn is equals to, yes, n is equals to u plus of a of n minus of. This also written as like this, Sn equals to u plus a of 2n minus 1 by 2 you can write. So both are same. The same equation should be expressed like this. Theta n is equals to omega 1 plus alpha of n minus of. So children, these are the equations in linear motion and these are equations in rotational motion. So you have to observe and you have to understand these equations are we can use only when the acceleration is constant. When the acceleration is constant, children. For examination, intermediate examination point of view, you write these equations only. Okay, right. When the acceleration is 0, we can write the equation should be like this. Equations of motion, acceleration is 0. Then very simple, when acceleration is 0, what to write? Here a is equals to 0. A is equals to 0. Then u is constant. U is constant. From that what to write? S is equals to u into t. S is equals to u into t. Now these we can follow this one in case of linear motion when acceleration is 0. Clear? And now in this case, what we are saying here, a is 0 we are saying. Now here angular acceleration is 0. Angular acceleration is 0. That means angular velocity omega is constant. And same thing, angular displacement is what, right? Theta is equals to omega into t. So these we can apply when acceleration is 0. Children, already we discussed equations of motion are applicable only when the body is moving with constant acceleration. If the body is not moving with the constant acceleration, then what happened? Let's see here. In this case we will write v is equals to dx by dt, rate of change of displacement, what gives velocity. Same manner a is equals to, we can write d square x by dt square or dv by dt. And next one is v dv is equals to a dx. So these are we can use in case of competitive exams only. V dv is equals to a dx. So now these can be written in rotational motion like this. One is omega is equals to d theta by dt, and alpha is equals to what? D square theta by dt square, or alpha is equals to d omega by dt, and this one is what? Omega dw is equals to d omega is equals to alpha d theta. So we can use these when the acceleration changes with the time. So children, this is the information about the equations of motion under different conditions, when the acceleration is 0, and when the body is moving with constant acceleration, and when the acceleration changes with the time. So I hope you understand. If you can understand this one, like, share the video and subscribe my channel to get the all notifications. Thank you for watching.